Like I said, we got to do part 2 of 4.7 today. Finish up the notes, get the second part of the assignment. Yesterday, what did we talk about? Or Friday?
That one thing where you put the numbers over 1. Yeah.
No, we didn't do that.
But no, you get the constant number. You put all of its multiples.
Yeah. That was from a few days ago, not Friday.
No, we didn't have Friday.
No.
I swear we did.
It was a long week.
Friday we used graphic calculators, right?
We hit the alpha button.
So-
we hit the y equals alpha.
So Friday gave us 2 functions, right?
The bing.
And it wanted us to describe the transformations that occurred from one function to the other. You guys somewhat remember that?
Yeah.
And then we graphed both of our functions on our graphing calculator and drew a sketch on our piece of paper. Everyone somewhat kind of hopefully remember that. So today, we're going to do part 2 of that. And let's just jump into it. Just jump into an example. Let f of x equal x cubed plus x squared plus 1. Write a rule for g, and then graph each function. Describe the graph of g as a transformation of the graph of f. So it wants us to write a rule for what's happening to g.
What's our rule?
I'm about to show you. Turn around. Thank you.
Who, me?
Uh-huh.
Why did you get pencil?
I got you. I saw what you were doing after I said that. I'm sorry. So it gives us a function. And then on letter A, it says g of x equals f of negative x. So it wants me to write a rule for g, and it's a transformation that's occurring to f. So if I were to ever give you, say, like in Algebra 1, f of like 3, how would you handle f of 3?
3x.
No.
F times 3.
That's usually f of x. What do we replace the x with?
3.
3. So I would go into my function and replace all the x's with 3, correct?
Oh, well, you should know like that.
Does that make sense? Same concept here. For my g of x, it says f of negative x. So if that's usually f of x, what did they replace the x with? In the f of x.
What?
It says f of negative x. It's usually x. What did they replace x with?
A negative
Negative
x.
x. So what do you think I'm going to do with my function?
Make it a negative.
Replace all the x's with negative x's. Does that make sense? Same concept as f of 3. If it was f of 3, I'd plug 3 in for x. F of negative x, I'm plugging in negative x for x. So I'm going to write g of x equals, and then from my f of x function, I'm taking the x out, putting negative x in its spot. Taking this x out, putting negative x in its spot. And the rest of the function stays the same. Does everyone see what we're doing?
Mm-hmm.
Does that make sense what I've done so far?
Wait. No.
Why not?
Why did you do that?
Because it told me g of x equals f of negative x.
Hold on.
A. Part A.
So we have to use the top, the equation
Yep.
at the top?
We're using
Oh.
this
I get
function
it now. I got it.
to figure out g of x equals f of negative x. So g of x just wants me to plug negative x in to my f of x function. Okay? So now let's simplify this a little bit. This is negative 1x to the third power. Correct? So what does an exponent tell me to do? Not add. Say I have 5 to the third power. What does that tell me to do?
Multiply 5 3 times.
Very good. 5 times 5 times 5. Correct? So if I have negative 1x to the third power, what am I doing?
Multiplying negative 1 times itself 3 times.
Negative 1x times itself 3 times, right? So negative 1x times negative 1x times negative 1x. Does that make sense?
Just negative 1.
So what's negative 1 times negative 1?
1.
1 times negative 1.
Negative 1.
Negative 1. And then x times x times x. X to the third, right? Anyone confused about that part. I feel like I confused it.
Yeah. Why did you? What did that even do?
I just did negative x to the third power.
But it's still right. It's right there.
Because negative x to the third tells me to do negative x times negative x times negative x, correct? So I guess let's do a negative x times negative x. What does that give me?
X.
Not just x. These are all exponents of 1, right?
1.
Whenever we're multiplying with exponents, I multiply the coefficients. So negative 1 times negative 1.
Oh, it is.
What?
Negative 1.
Negative 1 times negative 1.
1.
Positive 1, x. And if I'm adding exponents, what's 1 plus 1?
2.
2. And then I still have this times negative x. Is everyone okay with that? Simplified so far. Now I have 1x squared times negative 1x. So what's 1 times negative 1?
Negative 1.
Negative 1. Now I have x squared times x to the first. What's 2 plus 1?
3.
So I get negative 1x to the third, or negative x to the third. We okay with that? Okay. Plus negative x squared. So I have negative x times negative x. Anyone tell me what that would give me? Negative x times negative x.
X.
Squared.
X squared.
Squared, yeah.
And I have my plus 1. Is that as far as I can simplify it?
Why did you make it so complicated?
I didn't think I did, but you guys looked really confused.
Well, you could have just, like... Okay.
Does everyone agree that negative x raised to the third power expanded out as negative x times negative x times negative x? Yes.
But I thought you... If you did, like, negative 1 3 times, wouldn't that get rid of the 3? Oh, never mind. I don't know.
Did you figure it out, or did you just don't want to ask the question anymore?
I got it.
Got it. Okay. Can this be simplified any further?
I hope so. I don't think so. No.
It cannot. So this is my rule for G.
So is that the answer?
Part of my answer. That's the writing the rule for G. So my rule for G is g of x equals negative x to the third plus x squared plus 1. Is there any questions on that part? This means yes. This means no. Any questions? Next part tells me to graph each function, then describe the graph of G as a transformation of the graph of f. So, we're going to use our graphing calculators again today, and we're going to draw sketches of our graphs just like we did Friday. Okay? So, pull out your graphing calculators. Do we remember how to use the graphing calculators?
Yeah, okay.
How do we get to type in our functions?
Y equals...
Y equals.
Which one do we do first?
I would type in my original function first, so f of x.
Does it make a difference?
No. F of x equals x to the third plus x squared plus 1. Remember, after you get that exponent of 3 on that first x, you need to click the arrow to the right to get it out of the exponent position.
Wait.
So is there any confusion on what buttons we need to push here?
I actually deleted all of them.
I don't know how to get to that. Never mind.
You figured it out?
It is that
Do you all remember how to type it in, or do we need help? Let me know if you need help. Or ask someone around you. So we're typing in our f of x function, x to the third plus x squared plus 1. When you type that in, oh, here we go. I got graphs on here.
Did you not make
It looks something like this. Don't judge my graphs like you did on Friday.
You're still going to be bad.
It's not, I know, don't say anything about it.
I can't promise you.
Does everyone look something kind of like that for f of x?
Hold on.
It's not going to be perfect. I'm not an artist. That's why I'm not an art teacher.
Why not?
And then I'm going to graph my g of x function with it. The negative x cubed plus x squared plus 1. So go back to your y equals. Go down to the y sub 2 position. Type in negative x to the third plus x squared plus 1. And then graph it. What?
Why
Hungry.
is the bottom line wider than the top one?
So my g of x function
Oh shoot.
looks something similar. I'll use a different color.
I got myself confused.
Is this supposed to make a U shape?
Oh.
What's that class called?
Please quit talking. There's my g of x function, or something close to it. Did everyone get something that looks kind of like that?
That's horrible.
Anyone not getting that and not know where they messed up? Okay. Are there any questions on example A? Well, we're not done with it, are we?
No.
We wrote the rule for g. We graphed each function. Now what does it want us to do?
Describe the graph of G as a transformation of the graph of F.
Describe the graph of g as a transformation of the graph of f. So we can see this from our graph, or we can just see what we did to f of x. What did we do to f of x? And anyone have any ideas what my transformation is here?
As a negative.
Well, did I add or subtract anything in the parentheses?
No.
No, so is it a horizontal translation?
No.
That chart that we got on Friday will probably be beneficial today. Did we add or subtract anything outside the parentheses? No, so is it a vertical translation?
No.
No.
A reflection?
Did we have a negative outside the parentheses or inside the parentheses?
Yeah.
Yes, it's f of negative x, correct? So which reflection was that? Was it over our x-axis or over our y-axis?
How do you know? Is it Y?
Hmm?
Oh no, it's X. Alright.
Is it?
Well, yeah.
It's over our x-axis, isn't it? So I have the negative inside the parentheses. So I would say g. You guys can't see the red, can you?
How do you know if it's over the X or Y?
Hold on 1 second. G is a reflection over the x-axis of f. So if it's the negative inside the parentheses, that's a reflection over the x-axis. If my negative was outside the parentheses and it was negative f of x, that would have been over the y-axis. So it just depends on where the negative is. Does that make sense? Are there any other transformations going on? Am I multiplying by any numbers inside the parentheses or outside? I'm not. So this is my only transformation occurring. Am I now done with letter A?
Yeah.
Yes, I am. I've done everything it asked me to. Questions on letter A? Can I move to letter B? Okay, we're still using f of x equals x cubed plus x squared plus 1. This time it tells me to do g of x equals 3f of x. Any ideas how I'm going to do this one?
Yeah.
How?
Um,
Is my 3 inside the parentheses? No, so am I plugging anything in for x?
no.
No, they didn't replace the x with anything, did they? It's still f of x. What are they doing to the function as a whole?
Multiplying it by 3.
Multiplying it by 3. So that's what I need to do. I need to multiply my function f of x by 3. Does that make sense?
Yeah.
It does not make sense. It does? Okay. So 3 times my function f of x. Just like that. Because what does f of x equal?
F of x
Yep.
equals x3 plus x2 plus 1.
So I'm essentially plugging in x cubed plus x squared plus 1 in for f of x to this little formula. Does that make sense? F of x equals this stuff. So they're equal, they're equivalent, so I can plug this stuff in for f of x. So what do I have to do with that 3 here? If I have a number times a set of parentheses.
Just put it at the front, right?
Huh?
Isn't that the front?
What do you mean?
Oh, right, it already is.
If I have a number times a set of
Distribute.
parentheses. Distribute. Very good. My number 3 has to be multiplied by every term inside the parentheses. So what's 3 times x cubed?
3x cubed.
3x cubed. 3 times x squared.
3x squared.
3x squared. And 3 times 1. 3. Can that be simplified any further?
No.
No. So here's my rule for G. Any questions how we're writing our rules? If I've got something happening to the function, I'm probably going to be multiplying the function by something or adding or subtracting the function by something. If I have something in parentheses, I'm probably going to be plugging stuff in for x. Does that make sense? So, now I've got to graph each function. So go back to your graphing calculators. Hit y equals again. Clear out the original functions. You don't have to clear out y sub 1 though, because we already have that in there. I accidentally cleared it out.
Is there a way you can like just delete one thing?
Yep, go down to the second equation and click clear.
Well, no, like I accidentally added an extra plus and I should delete them out.
You'd probably have to clear the whole thing out.
What are we talking about?
Wow.
Or you could use your arrows actually. So, our original function f of x, once again,
Whoa.
I'm using the white one.
What is that?
Is it the same one as the first one?
Yep. So your first f of x is going to look the same as our previous graph. Just like that. And then type in your new g of x function, which is 3x to the third plus 3x squared plus 3.
Didn't you just move the whole thing out? 2.
So here is my new g of x function. I should have used a different color. There's my g of x in red. Everyone gets something similar to that.
Yeah.
Okay. So, based on what's happening to f of x and g of x on letter B, what is the transformation that is occurring here?
A vertical translation.
Am I adding or subtracting something outside of parentheses?
It's not a vertical translation.
It's not a vertical translation. Am I adding or subtracting something in the parentheses?
Stretch.
What is it?
Vertical stretch.
Vertical stretch by a factor of 3. Very good. So it's a G is a vertical stretch by a factor of 3 of f. Is that the only transformation occurring?
Yeah.
Yeah, it is, because my function's only being multiplied by 3. Not adding or subtracting anything anywhere. I don't have any negatives anywhere, anything like that. And I don't have any numbers being multiplied inside the parentheses. So the vertical stretch by a factor of 3 is my only transformation. Questions on B? We okay with that so far? Can I move on to my next example? Example 4. Let the graph of G be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph of f of x equals x to the 4th plus minus 2x squared. Write a rule for G. So this is essentially the same thing as we were just doing. It's just kind of written out a little bit different. On the last two examples, how many transformations did we have each? One each, right? How many do we have here? Two. I've got the vertical stretch, and then I've got the translation. Okay? So I'm going to take it one transformation at a time. What's the first transformation I have? Vertical stretch. Okay? So I'm going to call this second function h of x. So I'll call my last one g of x, because it wants the last one to be g of x. And like I said, I'm taking it one transformation at a time. So if it's a vertical stretch by a factor of 2, what am I doing to f of x? Multiplying f of x by 2. Right? So I'm just taking my f of x function and multiplying it by 2. Does that make sense? Any questions about what I'm doing for h of x? Remember, I'm using h of x because this is my first transformation of 2. Yes?
Those top two things are like the questions? Or is it all just one question?
I'm writing a rule for G using all the information from the first sentence. Okay? So my one set of directions is write a rule for G. Okay? So what do I do with that 2?
You distribute it.
Distribute it. Going to multiply it through the whole set of parentheses. Am I moving too fast for anybody? Okay. What's 2 times x to the 4th?
2x fourth.
2x to the 4th. 2 times negative 2x squared?
4x squared.
Negative 4x squared. Can that be simplified any further? No, it cannot. So this is my rule for h. This is my rule after my first transformation. After the vertical stretch by the factor of 2. But what other transformation do I have?
Of 3 units up.
So what is that? What kind of transformation is that? Vertical translation, right? So it's vertical translation up 3 units. So now this is my last transformation that I'm writing a rule for. So I can now call this one g of x. And so what am I doing to my h of x function to translate it 3 units up? What's that little formula we used Friday?
Wait, is it the facts one?
No.
No. Man.
Anyone have that chart down from Friday that they can look at for me? The vertical translation was what? F of x plus k is the formula I'm looking for, but it will be plus 3 here. So we're doing this to our h of x function. So I'm just adding my number, so my translation, the number of units, to my function. So once again, I'm using my h of x function here. So what's my h of x?
2x4
2x to the 4th
minus 4x squared.
minus 4x squared. And we said we're adding k to it. What did we say our k value was?
3.
Positive or negative 3? Positive, because it's telling me it's going up 3. So plus 3. Can that be simplified any further?
Wait, what would it be called if it was negative 3?
It would say down 3 units.
Okay.
Okay? Can that be simplified further? No, here's my rule for G. Do I have to graph it or anything?
You could.
Does it tell me to? No, so there's my answer. I'm done. Pretty easy, right? Hopefully. Hopefully kind of easy. So, that chart will help you a lot that we got in our notes Friday. It is also in your textbook in chapter 4, section 7. So use that chart to help you write your rules with all the transformations. If you got multiple transformations, take it one transformation at a time like we did here. We went from f of x to h of x, and then from h of x to g of x since we only had 2 transformations. If I had 3, I would do an h of x, and then I might do like a t of x, something like that. Until you get to your last transformation, you can call the last one whatever you want to find. So in this case, it's g. Questions on example 4? Last example for today. Look at that. Doesn't that look fun, Shelby? Doesn't that look fun?
It's triangle.
No, it's not.
Oh, it's up here.
Yeah, there you go.
What?
The function v of x equals 1/3 x to the third minus x squared represents the volume in cubic feet of the square pyramid shown. The function w of x equals v of 3 of x, or of 3x, represents the volume in cubic feet when x is measured in yards. Write a rule for w. Find and interpret w of 10. So it's essentially telling me to write a rule for w, just like we did on our previous examples. They just added it into a word problem for us. Still the same concept as we've done in the past few examples. So it wants me to write a rule for w. What does w of x equal?
V. 3x.
V of 3x, right? So, if I've got v of 3x, what is that telling me to do to my original function?
Put a 3 in front of the x.
Not a 3 in front of the x's.
You times the x's by 3.
Well, if that's v of x usually, what do they replace the x with? 3x. They took the x out, put 3x in, right? So that's what I'm going to do to my original function. I'm going to take the x out, put 3x in. Take the x out, put 3x in. Does that make sense? Get your heads up. Does this make sense what I've done so far? W of x equals v of 3x. So I'm just plugging 3x in for x. Okay? So I've got to do my exponents first. So I've got to do 3x to the third power. That's 3x times 3x times 3x. First off, what's 3 times 3 times 3? 27. And then x times x times x. X to the third. Minus 3x times 3x. What's 3 times 3? 9. X times x. X squared. Now I can multiply 27x cubed times 1/3. What does that give me?
Is it 3?
Huh?
Is it 3?
No.
Is it 9?
Is it 9?
Yeah.
Is it?
Yeah.
Are you sure?
Yeah.
Me too. 9x cubed minus 9x squared. Can I simplify that further? Nope. Here's my rule for w. Questions on that?
Yeah.
Is it it?
In the square.
So I wrote a rule for w. What does it say after write a rule for w?
10.
Find and interpret w of 10. There you go. So in my w function, I'm going to write it up here. Hold on.
Oh, you replace the x with 10?
Yep. W of x equals 9x cubed minus 9x squared. Now we're finding w of 10. Just like we said, we just replace the x with 10 throughout my whole function. So what is 10 to the third power? 10 times 10 times 10. 1,000. It's got 3 zeros, right? Minus 9 times 10 squared. What's 10 squared? 10 times 10. 100. 9 times 1,000.
9,000.
9,000. Negative 9 times 100. What? Negative 900. So 9,000 minus 900.
8,100.
8,100. So that's what W of 10 equals. And now it wants me to interpret it.
That's a big pyramid.
What does that mean?
Huh? Wants me to interpret it in the context of this problem.
Triangulated.
So let's look at the problem again. The function v of x equals 1/3 x cubed minus x squared represents the volume in cubic feet of the square pyramid shown. The function w of x equals v of 3x represents the volume in cubic feet when x is measured in yards. So this is w of x, right? So we're dealing with cubic feet. Or hold on one second.
Wait,
X is measured in how many units if it's w of x? Yards. So in our case, how many yards do we have when we found w of 10?
what is it?
Nope. What is
Divided
x?
by 3 or something?
What do we plug in for x? 10. So that's 10 yards, right? So what does w of x stand for? The volume in cubic feet, right? So what's the volume in cubic feet when I have 10 yards? 8,100 cubic feet.
In 10 yards?
That's good.
Whenever, for that square pyramid, yes.
You're telling me 8,100?
That's a lot of yards.
No.
So-
way.
This is just what all we did. You don't have to write this down. This is just written out better than how I wrote it out. So we wrote a rule for w of x, and we got 9x cubed minus 9x squared. Everyone agree with that? And then we found w of 10. So that equals 8,100, just like we found it, right? Because w of 10 equals v of 30, you can check that your solution is correct by verifying that v of 30 equals 8,100. So they plug 30 in for their v function, and they still got 8,100, so it checked out. Okay?
8,100 feet fitting a 10 yard.
8,100 cubic feet. We're finding the volume of that square pyramid. The volume of it. Okay? So if our x value is 10, if we have 10 yards plugged in for x, so the base of the pyramid is 10 by 10, and the height of the pyramid is 7, the volume of that square pyramid would be 8,100 cubic feet.
Wow.
Wow.
I don't even know
Good
how
stuff.
much would fit in there.
Questions about that? Here's our assignment. Page 217 through 218, number 17 through 27 odds. Once again, you do not take these graphing calculators home, correct?
No, sir.
So do you guys remember the name of the online graphing calculator I told you about? Desmos. If you're trying to do this at home, use your online graphing calculator of Desmos. It's free. Use it on your computer, your phone. You can type in your functions and it'll show you the graphs. I do want you to sketch your graphs on the paper. Do they have to be perfect? No, obviously mine were not. Are there any questions, comments, concerns about the notes, about my recording before I end it?